Okay, so now we're going to start by using the definition of derivative to calculate the derivative of different polynomials. Now, there's a nice little trick that is going to help us out, Pascal's triangle. Okay, so Pascal's triangle goes like this. So 1, 1, 1. Okay, now I'm going to take these two numbers and I'm going to add them together. It's 1, 2, 1. Okay? Then this goes 1, 3, 3, and 1, because 2 plus 1 is 3. Now, 1, 4, 6, 4, 1. This keeps going down. Now, 1, 5, 10, 10, 5, and 1. Okay, so 1, 6, 15, 20, 15, 6, and 1. All right, so this is Pascal's triangle. Pascal was an avid gambler. And so this triangle is used for different things involving probability, but it's also used for binomial expansion. Okay, so this first guy would be n, which equals 0, n, which equals 1, n, which equals 2, n, which equals 3, n, which equals 4, n, which equals 5, and n, which equals 6. Okay, so on the previous problem we did, we had d of t equals t squared. Okay, so the expansion of t squared, you'll notice that it came down to 2t. Well, it corresponds with this 1, 2, 1. Okay, let's try n which equals 3, and let's switch over to x's. Okay, so if I'm using n which equals 3, it's going to correspond to this sequence of numbers right here. 1, 3, 3, 1. All right. So let's say, give me just a second after that now. Okay. So let's start out with n which equals 3. And so we have f of x, which is going to equal x cubed, and we're going to try to find the derivative of x cubed. Okay? Some of y'all might already know that it's 3x squared by the power rule, because it just, what does it do? It spits out the number that's on top and drops it down by 1. So, but on this first test, you cannot use the power rule. You have to use the definition of the derivative, because this comes from very classical sense, because it comes from the entire ideas of differential calculus that was built upon by Newton and Leibniz, although I have certain qualms with giving Newton too much credit. Not about differential calculus, but about other things. I probably shouldn't get into a historical debate on YouTube. But let's try to figure out what the derivative of this guy is. So f prime of x is going to equal the limit as h tends towards 0. This is going to be f of x plus h minus f of x, now divided by h. So that's going to equal the limit as h tends towards 0. That's going to be x plus h, now cubed, minus x cubed, divided by h. Okay, so the binomial expansion is going to correspond to this guy right here. So I'm trying to cube this thing. Okay? Remember, I'm just going to put this in quotations right here. We had 1, 3, 3, 1. Okay. So this is going to equal the limit as h tends towards 0. X cubed, that's going to be the 1. Now plus 3 x squared h plus 3x h squared minus, plus h cubed minus x cubed divided by h. Okay, so my 1, 3, 3, 1 corresponds 1, 3, 3, 1. And this, I know this binomial is being cubed. So your first term is going to start out with x to the third power. Okay? Well, then what happens on your next one? X is going to go down to the second degree, and h is going to go up by 1. Then on your next one, x is going to go down again. So x is going 3, 2, 1, and then 0. And h is going 0, 1, 2, and 3. Okay? And just like on the previous problem, notice that this is going to happen a lot. You have a negative x cubed and a positive x cubed. So the first thing that we can do is we can say, you guys are out of the picture. Okay? And remember, the name of this game is get rid of that h on the bottom, because we cannot divide by 0. And notice that now every term within here has an h on it. So I'll do this with an extra step. That's going to be the limit as h tends towards 0. All right, so let's just write it like this. 3x squared h plus 3x h squared plus h cubed, all of that divided by h. All right? H and h cancel each other out. Cancel with one of them, and that 3 is going to become a 2. So that's going to be the limit as h tends towards 0. That's going to be 3x squared plus 3xh plus h squared. Well, we managed to eliminate the h on the bottom of the problem. So at this point, we can just say, let everything with an h on it go to 0. So this guy is going to go to 0. This guy's going to go to 0. And the only thing that's going to be left is that term right there. So the derivative of x cubed equals 3x squared. Before I start another video, let's try n which equals 4. Okay. So, now, on Pascal's triangle, this is going to correspond to n which equals 4, which is 1, 4, 6, 4, 1. Okay? So, let's try this. F prime of x is going to equal the limit as h tends towards 0 of f of x plus h minus f of x, and now divided by h. And this will equal the limit as h tends towards 0. Right, so our f of x is that x to the 4th right there. So that's going to be x plus h to the 4th power minus x to the 4th power, now divided by h. Okay. Now, according to Pascal's triangle, what are we going to use? 1, 4, 6, 4, and 1. So 1, 4, 6, 4, 1. Okay. So this is going to be the limit. Now as h tends towards 0. Now this is to the 4th power, so you should always start out with just, this is x to the 4th. That's going to correspond with the 1. Okay. Now, when I go to the next one, which is going to correspond to the 4, this x is going to go down by 1, and h is going to go up by 1. Right? So, plus, now 4 x cubed h plus 6 x x squared h squared plus 4x h cubed plus 1, which is h to the 4th, minus x to the 4th, all of that divided by h. Okay, now this should be done in 2 steps. I just don't want to rewrite everything and make this video longer than it has to be. So x to the 4th and x to the 4th cancel each other out. Okay? And now I look at it, everybody in the problem has an h on it, and so I can start canceling those out. H and h will cancel out one of those. That 3 will become a 2, and that 4 will become a 3. And so we end up with the limit as h tends towards 0 of 4x cubed, 6x squared h plus 4x h squared plus h cubed. Okay, now we've eliminated the h on the bottom, which is the entire goal of what we're attempting to do. Notice every single term has an h on it besides the first term. So if I plug 0 into this problem, that's going to become 0, that's going to become 0, that's going to become 0. And so that will equal 4x cubed. And it doesn't matter what the power is. You're going to have the same process of the first term and the last term will cancel each other out. And then everybody's going to have an h on it. That allows you to cancel the h on the bottom of the problem. And the only thing that gets left over, which is the definition of the which is the derivative through the definition, becomes the first term of that problem.